restrictions are. So when we talk about sine, visualize your sine curve. Visualize, this is your sine curve. Remember, catch it, it's going to come up here, it's going to stop. It's going to go down here, it's going to stop. So, look at, you have one positive, one negative. From negative pi over 2 to positive pi over 2. So sine has a restricted domain of negative pi over 2 to positive pi over 2. Easier way is what quadrants does is this cover. 1 and 4. So you're in quadrant 1 if it's positive, in quadrant 4 if it's negative. Let's do tangent. Tangent says, oops, I got asymptotes here, and my tangent curve goes like this. See why it fits like right with the sine curve? It has a natural boundary. Anything out to the left or the right of it is going to fail a horizontal line test. So tangent says from negative 90 to positive 90 as well, but I just got a little problem with the 90. I have no tangent at 90. Again, quadrant 1, everybody's positive, and quadrant 4, tangent is negative. Now the one that works a little differently is the cosine curve. Cosine says, start up here, this is my 90, this is my 180, halfway through my curve is 180. If I go backwards, I fail a horizontal line test. So therefore my cosine starts at 0, there's my 90, quadrant 1, there's my 180, and then I fail. So my cosine goes from 0 to pi. Quadrant 1, everybody's positive, and in this case, it's using quadrant 2, where it's negative. Those are the things you need to know. Now, when we ask you what arc, if we say arc sine, sine negative 1, cosine negative 1, tangent negative 1, arctan, that's asking for an angle whose restricted sine is, whose restricted cosine is. So when this says arc, it means give me an angle, and technically it used to be give me an angle whose arc is, that's where the arc came from. You know when you do an angle, so if this is your angle over here, this is the measured arc. Isn't your central angle the same as your measured arc? So this really does stand for give me an angle whose arc is. So it reverts to give me an angle whose sine is, whose cosine is, whatever it is you're doing. Now, cosine and sine and tangent is what you're looking at. You only have the 3 to look at. So in this case, I say, where is sine positive? Well, everybody's positive in quadrant 1. You're only going to get two quadrants on your restrictions. So drop your triangle in quadrant 1, and yes, this is a 30-degree reference angle, so my angle is just quadrant 1, pi over 6. Now, if you put this in your calculator and you say second sine 1/2, it gives you 30-degree angle. It gives you that angle, because your calculator does a true inverse. It only gives you the one restricted angle. These are a little bit harder, and I talked to you yesterday about this. Where is sine restricted? Sine is restricted from quadrant 1 to quadrant 4, from negative 90 to positive 90. The zeros and the ones are on the quadrants. So sine is the y. I'm looking for a y to be 0. And lo and behold, I found it. Right there. So the sine of 0 degrees, or 0 radians, is 0. Okay. Give me an angle whose sine restricted, these are restrictions, is 1. Again, sine goes from here to here. The sine is the y value, right there. So I'm at negative 90 to positive 90. I'm at 90, pi over 2. I can't be anywhere outside of that domain. Cosine. Give me a restricted cosine. Cosine is restricted to what quadrants? 1 and 2. So right away I just go like this. I notice it's a 1. A 1 and a 0 are my quadrantal angles. So I again label this. and the cosine is my x. I say, oops, there's my x of 1 at 0. If I put this in my calculator, second cosine 1, it would come back and say 0.
Oh, I read it.
Okay.
I was coming from a meeting.
Okay, it will give me the 0. Questions on these? Some of you are telling me not understanding. How do these look? Kind of getting this? Okay. I want you to be able to get this. Okay, I have an angle whose tangent is restricted tangent. What quadrant is tangent restricted to? 1 and 4. 1 and 4. Because remember, tangent looks like this. From negative 90 to positive 90. If this is quadrant 1, and this thing keeps going, 2, 3, 4, 1, 2, what comes before the 1? 4. So this is where your tangent is restricted to, here to here. Okay, here to here. My tangent is positive. Everybody's positive in quadrant 1. So I lay out my parts. If it's easier, unrationalize this guy. It would be much easier to look at. And yes, this is a 30-degree angle. So this is pi over 6. If you didn't and you found the missing, you have to look for the missing side. And then you'd see it fits into your special triangle. Arctan of negative 1, where is my tangent restricted negative from this and this? Quadrant 4. I drop a triangle, 1 over 1, and there's a 45-degree angle. Now, I can only go from negative 90 to positive 90. So this angle has to be negative pi over 4. It can't come all the way around like this, because it can only go from negative 90 to positive 90. If you put it in your calculator, it will give you negative 45. We did this yesterday. It gives you that negative angle in quadrant 4. Quadrant 4 means you went down this way. Questions? This is why I kept this part separate. Inverses work a little bit differently, because our curves, even the tangent and the cotangent, don't have the horizontal line test. So we have to cut it off. We have to restrict it. And if you see arc, whether you see small a with any of your functions, large a with any of your functions again, sine negative 1 or any of them tan negative 1, even a small s, these all mean an angle whose sine or cosine, sine is in the restricted domain. These are my inverses. Okay? And your calculator, when you say second sine, second cosine, does only a restricted angle. Okay. Tan again from 1 to 4. So where is it negative? Between 1 and 4? In 4. So I lay this out again. It has no bottom. It has no denominator. So I put it over 1. Y over x. Oh, there's my special angle. There's a 60-degree angle. Now remember, in this quadrant, I have to go down here. Negative pi over 3. I wrote over the negative sign. Okay, again, now look at what's the difference between this one and this one. One is negative, one is positive. Is it the same reference angle? Same reference angle. This guy's just in quadrant 1. This guy was in quadrant 4. So this little reference angle will still be 60, but in quadrant 1, pi over 3. Yes? Okay. All right. This, I don't know where this writing came over this thing, but just try to bear with it. I think something happened to it over here somewhere. So this is asking for the sign of -1. Whose angle has a sign in the restricted domain of radical 3/2? So right away I say my sign is restricted to 1 and 4. Where is it positive? 1. I don't know where this writing came from. Something must have jumped on there. So my sign is restricted to 1 and 4. It's positive here. I set my triangle up and I say, whoop, 60-degree angle. Tangent restricted to 1 and 4. Always start where your restriction is. If you try to make that half circle, it's always going to be 2 quadrants. They're always going to be next to each other. 1 and 4 or 1 and 2. Start with a little loop like this so you won't be forced to go out of this. Tangent is negative down here. Again, we saw that before when they unrationalized it. We unrationalized it. And again, that's a 30-degree angle, but it's -30. Any questions so far? Now, this last part is what we were attempting to do yesterday by drawing the inverse function ourselves. But what this does is, if you look at it, it says, normally, here's my cosine curve. But, well, let's look at your cosine. I'll do this one first. Let's look at your cosine curve. This is pi/2. This is pi. This is 0. Okay. Normally it looks like this. If I take this coordinate, I say pi/2, 0. This is my inverse function. Remember, for a true inverse, we swap them around. So now, somewhere over here, it will be 0 pi/2. So look at it this way instead. When the function was -1/2, down here, -1/2, because I'm going to cut it off right here. When it was -1/2, what angle was that? So, I don't know, so let me draw it and find out. So -1/2 tells me I'm in quadrant 2 because it's restricted to 1 and 2. Doesn't it show me down here in quadrant 2? Right? I'm restricted to 1 and 2. Let me just lay this out so I get this right. This is a 60 degree, so if I come here, this is 120 degrees, or this is 3 pi/3, so therefore, this is 2 pi/3. So I have an angle that's 2 pi/3, and it has a cosine of -1/2. If you look up the cosine of 120, you get -1/2. Now, on my inverse curve, they have to swap. So, who has a -1/2? Oh, this is 2 pi/3. So all they did was swap them on your inverse curve, which I showed you yesterday, but I said I have a hard time drawing these, because this is your inverse curve. Here's your cosine curve. It starts like this. But remember, it has to be a reflection in there. And it's not an even reflection line. That's the hard part, because it's not a one-to-one. It's not one-to-one in there. So this guy says, oh, I have an angle whose cosine is -1. Look, I have an angle whose cosine is -1. If my cosine goes from here to here, oh, that must be my quadrant angle. Isn't that 180 degrees, pi? So pi has a -1, so here this becomes pi. The inverse says take the x and y and swap them around. So it's probably easier, what I'm saying is look at it this way. So where is pi/6? What quadrant is pi/6? 1. It's a 30-degree angle in 1, and I want to know the cosine. So the cosine is radical 3/2. So this guy right here has to be radical 3/2. All they did was put it on an inverse curve. That's all they did, just a little bit to confuse you. not to confuse you, as my husband would say, this is how we graph the true inverse. We take your original, we restrict the domain, we take those parts, we swap them around, and we graph those. Now graphing them on the same axis again is hard because, see, they relabeled their axis by whole numbers. Look at their x-axis, they relabeled it. If you take your original one where you label all your angles, and then you have to swap them on the original one, you kind of have to convert in your head. O pi is 3.14. O pi over 2 is 1.57. You kind of have to get a feeling for where your 1 is, where your 1.5 is, where your 2 is. You have to get a better feel for that. But I said I won't require you to graph the inverse, but you just have to know how to restrict your domain, how to find what quadrants they're in, how to find the restricted parts. Now they did the same with tangent. Tangent said for pi over 4. You have a 45-degree angle. What's the tangent of a 45-degree angle? 1. There's your 1 right there. There's your 1. This is their inverse, don't forget. So they swapped these out already. Normally on my tangent curve, it would be this. All we did was interchange that. So they have another angle here of negative pi over 6. So I find my negative pi over 6 in my tangent. I find this is my negative 30. I lay this all out, and what's the tangent? Y over x, 1 over radical 3, and in this situation, it's negative. And you don't have to rationalize your denominators either. So do you see what we're doing for those parts? We're just finding whatever the missing part is. If they already inverted it, they already did switch them around. So switch them back. What you're doing is finding the missing part. Make sense? Questions on any of your inverses?
This is the quadrant thing.
Let's investigate your sine curve. Here, everybody draw right here your original sine curve. Make your 4 quadrants. You don't have to do the negative, you just all the way, just a little bit. So your 4 quadrants says 0, 1, 0, negative 1, 0. And just go backwards for me, just a little bit. So this is your regular sine curve. What is the domain of your regular sine curve? Okay, my domain is negative infinity to infinity. I can use any angle that I like on my sine curve. What's my range? Good. Okay, now, it says over the interval from 0 to 2 pi, I'm looking from here all the way to here, in what locations do the y values repeat themselves? Look up here for 1 second. This is what they mean. I have a y value here of 0. I have a y value here of 0, here of 0. I have a y value of positive 1/2. I have a y value of positive 1/2. I have a y value of negative 1/2, negative 1/2. So for sine, in what quadrants do they repeat? Like, look for symmetry. Maybe that's a better way to look at it. Isn't this part symmetric over here? What quadrant are these two things? 1 and 2. Because doesn't 1 go from 0 to 90, 2 goes from 90 to 180? So from quadrants 1 and 2, they repeat, and then where else? Here's my quadrant 3, here's my quadrant 4. So quadrants 3 and 4 repeat themselves. Okay, now, let's just go one step further than they did. In quadrant 1 and 2, what are my y values, positives or negatives? Positives. In quadrants 3 and 4, they're negatives. So we want to ask ourselves, does this sine curve, if I want to make an inverse curve off of this, an inverse function, am I able to make it off of this original sine curve? Does this have a true inverse? No. Why? Good. No, because it does not pass a horizontal line test. Okay? So now, look what they're asking you to do. They're asking you to graph this from negative pi over 2, negative 90, to positive 90. Because what does that do? This is where it fails the horizontal line test. This is where, and write this down, it is restricted. So they gave us negative pi over 2. I'm not crazy about this graph, but here's the y-axis right here. Here's the x-axis right here. So here's your 0. So you're the 0. This is going to the 1. This is going to the negative 1. So your sine curve should go like this. If it comes out of here, I failed. If it comes out of here, I failed. So do you see the cutoff? This is your domain for sine curve. So your domain now for the restricted sine curve is negative pi over 2 to positive pi over 2. Did the range change? No. Okay? Some of the questions I like, some of them I'm just kind of breeze over because some of them I don't like. So if I look at these pieces right here, do I cover all the positives and all the negatives at once? So where is it positive? Up here in quadrant 1. And where is it negative? In quadrant 4. So therefore, my sine curve is going to use quadrant 1 and quadrant 4. It's a little bit easier to see. No, for like this whole thing. That was number, I don't know. That was number 5.
So you're not going off of like the original 1, 2, 3, 4. You're going off the curve itself.
The curve itself. So now look. When you broke this off and said don't pass by here anymore because you failed my horizontal line test, you went from 0 to 90. So isn't that quadrant 1? Think of your circle. From 0 to 90 is here, quadrant 1. Then you said, well, let me just go backwards because I didn't fail yet. I go backwards until I hit this spot and I say, whoops, I failed. So when I go backwards here, what quadrant is this? 4. Because technically, isn't your sine curve so continuous that it always goes 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4? So before a 1, don't I get the 4 from the one before?
Yeah.
Right? So this is nice to see that it actually shows us again, like we did yesterday, where your restriction is. It does want you to sketch the reflection, but I'm not going to have you sketch the reflection. Because you can't, your y equals x line does not go exactly through these quadrants. Because this is 3.14 divided by 2. So this is like 1.7 something. Your 1 would be over here somewhere. Over here. So your 1, 1, your y equals x line would have to go here. Do you see what I'm saying? Let's give it a try. Make this guy, if this is pi over 2, in your calculator, do pi divided by 2. What do you get? 1.7, 1.5, is it 1.5? 1.57 something, right?
Yeah.
So now I have to like section this in half. So if I do 0.5, 1, 1.5, my 1 is going to fall right about there. This is where my 1 is going to fall. And again, this is my negative 1.5 something, and then I section it 0.5, 1, like thirds. This is where my negative 1 is going to fall. Your y equals x line is where the 1, 1 is, and the 1, negative 1 is. So here's my y equals x line. I really stink at drawing these. I apologize. I'm horrible at these. But your inverse is going to go like this. Barely like that. But what it does is it swaps around the x and the y. I'm not concerned about you drawing the inverse as much as I am just you understanding where your restricted domain is. That's what I want you to see. So now, look at number 9. Look at number 9 for me. What is the value? Let me look at just number 8. Is that okay?
Sure.
8. So the domain and the range for the inverse, we said have to swap out, right? So the range for your original sine curve is now your range, is your domain for your inverse curve. So your inverse curve domain will say -1 to +1, because didn't we change this now to 1s? We changed it to 1s on you. Your range will say -π/2 to π/2. And again, I'm not concerned about that. Now, look at number 9. What is the value of y is equal to the sine of π/6? What angle is π/6? 30. So in here, this is my π/2. Here's my 30. What's the sine of 30? What's halfway between 0 and 1? Half, right? The sine of 30 is 1/2. What is the sine of -π/6? -30, -1/2, right? -1/2. And again, it says it now in the reverse. Number C gives you the reverse, gives you the inverse. It says, give me an angle whose sine in this little piece is 1/2. So there's my +1/2. What angle is this? 30. π/6. It's just asking you in the reverse way. See it? It's just asking you reverse. It says, using your inverse, what angle in this little piece right here has a sine of -1/2? -30, right? -π/6. So do you see how it's using its inverse? Look at number 10. It says, a student says that the inverse sine, an angle whose sine is 1/2, should be 5π/6. Is this true or false? False, because what? It's π/6, it's π/6 here. 5π/6 is not in here, it's out here somewhere, isn't it? 5π/6 is down here somewhere. I can only look from here to here. We agreed that you can only take one quadrant for positive, one quadrant for negative. So 5π/6 is not in my restricted domain.
So, like for 9, 8, C, D, you're finding the sine or whatever, like how do you know the triangle to like draw?
Well, that is your 30-degree triangle, but we were just trying to use our graph right now. And the only reason, Azure, I'm trying to use your graph is because, do you see the first two, A and B, say, I'll give you the angle, you give me the sine. C and D said, I'll give you the sine, you give me that angle. But we're in the same section right here.
So you don't want us to do number 7?
No, I just wanted to skip around on this. Are we okay with that part so far? All right, so let's restrict your domain. I like the restricted domain part on this. I don't like the drawing the inverse on this, because right now that doesn't mean as much to you as just swapping it in your head. So come down to now the cosine. Let's see what they say about cosine. Yes. Let's sketch your cosine curve right here. All 4 quadrants, and then just maybe go 1 or 2 behind this. So we have a 0, a 1, a 0, -1, a 0. And just sketch a little bit this way. Again, we have the continuous curve. What's the domain of your regular cosine curve? All real numbers. And the range? Good. -1 to 1. Okay? Now, it's asking you this. On the intervals from 0 to 2 pi, from here to here, what quadrants repeat the same y values? So look up here 1 second. if this is quadrant 1 and the y is positive, this is quadrant 2 in here, and the y is negative. This is quadrant 3 in here, the y is negative. This is quadrant 4, the y is positive. So which two quadrants is y positive? 1 and 4. Everybody agree? Which two quadrants is y negative? 2 and 3. Okay, so good so far? Now, it's going to say the same thing as we just said. Does this in itself have an inverse? No, because it fails a horizontal line test. So when we cut off our horizontal line test, we cut it from here. We pass through the 90. We stop at the 180. And this is what I don't like about this one. So we're not going to graph this. We're going to take this out of here. And we're going to graph from 0 to pi. I don't like the way they do their cosine one. Their cosine one is not in here. So they say, I think they made a mistake here. We're going to graph from 0 to pi. So we're going to start at your 0, and here's your y-axis here. Here's your x-axis here. Sometimes they're a little hard to find. So we're going to start at the 1. We're going to come down to the 0. We're going to come down here. Your cosine curve is using this little bit. Because if it goes here, wait, Jen, let me give you a homework sheet. Just start 1 side. And if it goes past here, we fail. Agree? Agree with me, guys? Okay, so now, basically they're asking the same exact thing that they did before. If I'm looking for the cosines of pi over 6, 30, that's in here, right? This is my 30. X this guy here. It just so happens to be the cosine is radical 3 over 2. Then look at number C, letter C. They ask it in the inverse way. So if I want an angle in this little area who's restricted to a positive cosine of radical 3 over 2, what angle is it? Pi over 6. See how they ask the inverses? If I'm looking for 5 pi over 6, this one, yeah, I do have 5 pi over 6. Because I'm going from 0 to pi. So I do have a 5 pi over 6. And that would be my negative radical 3 over 2. And then the D says, what angle in my restricted domain has a negative radical 3 over 2? That is my 5 pi over 6. That's just the way that they ask it backwards and forwards. Okay, one more, the tangent. The tangent has one more. Let's just hit your tangent. Radical 3 over 2. They see it, for me, they should have used the pi over 3 one to give you 1/2 and you can see it easier. But if we drew your triangle, it would be radical 3 over 2. The goal at that was just looking at the inverse parts of it. Now, tangent. Let's everybody draw your tangent curve. I have a little problem at the 90s. There's where my asymptote goes, those odd 90s and pi over 2s. My tangent is fitting in between here. So, this one had a funny domain. It was real, except where x was equal to n pi over 2, where n was any odd integer. What was the range?
Negative pi over 2.
Negative infinity to positive infinity. Range. All ones. Yeah. Now, I look again. Now watch what they're asking here. Between the 0 and the 2 pi, it repeats from here to here. This is quadrant 1, this is 2, this is 3, this is 4. I just didn't draw this other piece here. So, quadrants 1 and quadrants 3. repeat themselves. Kind of just like your sine, right? Quadrants 1 and 3 and quadrants 2 and 4. Now, again, this does not have an inverse until we restrict it. And here's our restriction. Now, the only problem is, remember, tangent does not have a tangent for 90 and negative 90. So the only difference from the sine is it says, don't try to do my tangent at 90. So I'm just a soft bracket. But again, it's asking the same thing. So if we graph this from negative 90, here's your y-axis, here's your x-axis. Here you are. These are where your asymptotes are. Here's where your tangent goes. So isn't it positive in quadrant 1 and negative in quadrant 4? Does this help a little bit? Walking through these? Again, it's going to go through where is my angle, where's my